All right, this question is going to look at composition, and we did this warm up in class, but we're going to focus again on some different parts of it. So we were given equations here. One's named F and one's named G and one's named H. And so when I focus on part A and it says find H of G of X, so a little reminder that that open circle does not mean multiplication. It means you're plugging one function into the other. So I kind of like writing it like this. Those mean the same thing. Now, remember that when you plug stuff in, you're just replacing it or substituting it. So the first thing I focus on is what's inside the parentheses here. Start with the innermost, which is g of x. And when I look back at what we were given in our problem, g of x is the name of a function, but it says that that's equal to x minus 3. So you can replace the name g of x with the expression x minus 3. They're equivalent. So since I'm trying to come up with this new expression, I don't want names in here. I want what they're equal to, which in this case is x minus 3. Now, once I replace that, I have another math problem to do, which is h of x minus 3. When I look back at the instructions we were given and I see h of x, it's equal to 5x plus 4. So remember, that means if you were doing h of 2, you would write down the h of x function, and instead of x, you would replace it with 2. So everything that's being replaced is right there. So it's kind of nice to think of h as just like this function of 5 times something plus 4. So if I think of h that way, to not have the h written here, I would have to write out what h is. H is 5 times whatever you're plugging in plus 4. And now I want to use what's in here as what I'm plugging in, x minus 3. I'm now done with all of the plugging in, and I just need to simplify. So here there's a multiplication to do. And I can combine these like terms, making this 5x minus 11. So h of g of x, okay, that's a new equation you get by combining them together in this order, is equal to 5x minus 11. The second question in our warm-up asked us to do f of g of x. So again, f of g of x, oops. Remember, you see it this way, and you remember that that open circle does not mean multiplication. And then we want to think about it this way. And so the first thing we want to focus on is what is g of x. So g of x, according to our instructions, was x minus 3. So that's getting replaced there. And now this time, this notation means we want to plug this into the f function. Okay, so when we look back at our instructions and we look at the f function takes whatever you plug in. It does x squared minus 2x plus 1. So if you're plugging in 1, you end up squaring 1 and multiplying it by negative 2, etc. So if we want to plug in something complicated like x minus 3, we first just want to focus on writing out the f function. It was x squared. So whatever you're plugging in gets squared, minus 2 times x, and then let me look back so I don't mess it up, plus 1. But instead of plugging in something simple like a number here, you're plugging in the entire expression of x minus 3. And then you have to be a little careful about the arithmetic here, especially with this x minus 3 squared. X minus 3 being squared means specifically you have to multiply out an x minus 3 times another x minus 3, which will be x squared minus 3x minus 3x plus 9, which is x squared minus 6x plus 9. So this portion multiplies to be x squared minus 6x plus 9. Here you have to distribute the negative 2 to everything that follows then that parentheses. So that'll be minus 2x plus 6. And then we have a plus 1. And now we'll focus on combining like terms. So x squared is the only x squared. There's a minus 6x and a minus 2x, which will add up to a minus 8x. And then there's a 9 plus 6 plus 1, which adds up to 16. So this tells us that when you combine f and g of x in this way, as f of g of x, you get a new expression, which is x squared minus 8x plus 16.